Just wanted to do a quick review of triangulation, as we learned that as the basis to finding star distances. So let's do this triangulation review. And let's take the problem that we had in the quiz and figure out how to do this properly on paper. Well, the problem basically is, and I'll write it in the essential question, is what is the width of a river if surveyors measure a 50-meter baseline at one end, and at each end they get I think we said 45 degrees at one angle, at one point, and 70 degrees. Okay, that was basically the problem. So if we were to take a look at starting a baseline, so there's a river going through, the baseline itself has 50 meters. So we're going to take a ruler and establish a base of 50 meters. Now, in using the ruler, a couple of things. You have a millimeter scale, it has to be pretty accurate. Obviously, if we translate the 50 meters into 50 millimeters, that would be 5 centimeters. That would give us the baseline. So I'm going to go ahead and very carefully draw here from 5 all the way to 0, 0 to 5 centimeters, knowing that that's 50 millimeters. Each millimeter then will be corresponding to our 50 meters. So now that I've drawn the line, I'll label it 50 millimeters, understanding that I'm corresponding this 50 meters that the surveyors took to our 50 millimeters here. Now when I go to measure an angle at one end of 45 and an angle at the other end of 70, I'm going to use a protractor to do that. And I wanted to just kind of review the use of the protractor. If you take a look at a protractor, just a couple of things. The protractor itself, I'm moving it such that it's not on the line per se. I wanted to point out to you that that right there is the base of the semicircle. So you have the other base at that end, and at this end, if you will, that's the point in the center of the circle, and then you start counting degrees, 10, 20, 30, etc. And then on the other side, it goes all the way to 180, and then in reverse, it starts on the inside, 10, 20, 30, and so on. Now the question is, what I've seen in some of the kids' works is to make sure that you know that you point that right exactly in the center. So to illustrate that, I'm going to go ahead and make this 50 millimeters. I'm going to make it a red dot right there, so it's easy to see that that's the point A of that initial 50 meter length, and this one is B. But I'm marking that red so I can go ahead and put the first angle of 45 degrees. Remember, that's what we're trying to do, it's 45 degrees. So all you do is line it up properly. Now, it cannot be in any way except, notice I have it off center. I'm going to go ahead and move that right into that crosshairs where that's the center of the circle in this protractor. And now the question is, how do I do the other side on the right hand side? I got to line it up with the base of that semicircle right there. It's not quite lined up. I'm going to line it up right there. And then I look to see that that point is right exactly in the center of that crosshair. Now I can go ahead and, keeping that in place, I can count 45 degrees. So to count 45 degrees, I go 10, 20, 30, 40, 50. Now it's somewhere in between, but notice that I can take that in between from the line right here between the 100, and notice that it says 120, 130, 140. So somewhere in between is the 45 that I'm measuring. So it would have to be approximately right there. Notice I did a small mark. Maybe it's a little bit off, but you get the idea that that's approximately where 45 degrees is. Now, I'm transferring a paper that the surveyors did into our paper, so I'm going to go ahead and now connect it with a straight edge and basically connect the line. So now I have my dimensions done. This is a 45-degree angle. You do the same thing on the other side. I'm going to make this dot blue, a little bit bigger than it should be, but just to illustrate it, I'm not sure if you can see that in color, but that's the blue. And in the same way, I want to measure now a 70-degree angle. So I'm going to go 70 degrees past 45 to about 70 degrees and see where it takes me. So I'm going to take, once again, my protractor, line up. It's smeared a bit, but no big deal. I'm going to put it right on that line. I'm going to zoom in a little bit so you can see it. I'm moving it right on top. The crosshairs has to be right on top of that blue line. And I'm lining up on this side the baseline of the semicircle right on the line itself. So bottom line is right there, a little bit. That would be about right, perfect. Now I'm going to go ahead and zoom out a little bit, and then I'm trying to find 75 degrees. Well, in this case it's easy because it's on the outside edge. So 10, 20, 30, 40, 50, 60, 70. So 70 would be approximately right there. I'm going to move it down so you can see it. So I've selected 70 degrees to there. Now I can connect with a straight edge from B to that line directly. Okay, so now I have a triangle A, B, and C. Now I know that this is 70 degrees. Now, just in case so we don't forget, is that on the side, you might want to make a note that's basic to geometry. Adding all these three angles should equal 180 degrees. So all angles of a triangle must add to 180. Okay, so what is this angle here? If I call that angle X, it would be 45 plus 70 degrees plus X equals 180. So X, if you solve for that, would be 65 degrees. So that's 65 degrees. That's easy enough. Now, why do we need that? I'll tell you in 1 second. But what we're going to try to do is drop a vertical line from C onto the baseline, and that consists the width of our river. From C, that's where the surveyors ended up pointing their transits to figure out the angle. From A, came up with 45. From B, they pointed to the same point, and they came up with 70 degrees. Now, how do we find the width of the river? Well, if the river is going this way, if this is either a rock or a tree, and here's our baseline where the river is going, that the surveyors laid out that they could measure. So our river is going this way. So what we're trying to do is figure out that width of that river. In order to do that, we got to drop in a perfect vertical to it, and that's the key. The question is, how do we do that? You could take the protractor and attempt to line it up. This is small enough a problem that could probably work. If you go right to the line and this happens to coincide that 90 degrees is right there, you line up the line, the crosshair perfectly, and then you can basically draw the line, which is what I suggested that you do. So I'm going to go ahead and use a different color. I'm going to go ahead and mark. There's the 90. So it's the point C, if you will, and there's my crosshairs right directly. Okay, so I'm going to go ahead and mark that, which is, if you take a look at this, it will be right about there. Now what that permits me to do is, I'm going to take that 90 degrees from right there and drop it directly there onto the line. Now that is a 90-degree angle. Okay, has to be a 90-degree angle, and that will give us the width. Now how do I get the width? This is what we're looking for. The width is D. That's what we're aiming to figure out what the width of the river is. So we just simply measure the distance from the bottom, the base itself, to point C along that blue line that we've drawn, and we get about 36, 37 degrees, or 37 millimeters or so, excuse me, from right there to about 3 centimeters is 30 millimeters, so about 36 or so. D turns out to be about 36 millimeters, or 36 meters in the width of the river. Okay, I hope that helps to illustrate how to do this problem. It's pretty straightforward and easy. I'm going to leave you with a practice problem that I'd like you to try, and that is, I'm going to give you a baseline of 6 centimeters and two angles. One is 45 degrees and the other one is 70 degrees. Now it's very similar to the one that we've done, but we've enlarged the base more. So work out the problem underneath it, make sure that you get the accurate answers for it, and tell me what is the width of the river. So this is for you to work out, please. Thank you.